Welcome to the solution video of the intermediate puzzle Pandora's Box 2, and it was published, let's see, on April the 17th of 2024. And the solution approach I'm going to take is from ex-follower Bader, and what he does is some careful measurements. Well, first of all, for convenience, make visible the points and draw some perpendicular lines. I'm drawing a perpendicular line to, let's say, a horizontal line to the point M, and I'm drawing a vertical line to the point N. And I'm going to choose a unit length of 1 that is equal to the small red square side. I can do that because I'm just looking for a fraction. Well, the question is, I forgot to mention, is of these 5 squares, what the fraction of the larger square, what fraction is colored? So what fraction is covered by the 4 colored squares? And here we have a diagonal. And if I choose this length to be 1, then I can easily see that this length is also 1 because of the 45 degree I have over here. So we have length 1 over there. Here we have a small right triangle, and let's say this longer side has length 1, and the smaller side again has length A, and the smaller side has length 1. Because it's a square, it's easy to show that this is a congruent, this small right triangle is congruent to this one. So we have again length 1 over there and length A over there. And because again we have here another congruent right triangle, so I leave that to the viewer to prove that those triangles are all congruent. So we have 1 over there and we have A over here again. Okay, now we're going to look at this right isosceles triangle. We have again here 45 degrees, 45 degrees. So we know that because A is over there, we have A over here as well. And now we're using the fact that this is a square, so that means that this remainder is A plus 1. Yeah, that's the blue side length, A plus 1. So we have completely covered the top side. Now we're going to look at the right side. Here we have A, obviously A. Here we have 1. Just continuing down, again A. And again, because of a right isosceles triangle, remember 45 degrees, 45 degrees right angle. So here we had A plus 1. So that means that the remainder of the right side is A plus 1. And now we're gonna equate those two sides, because we knew that the large is also a square. So on the top side we have 2A plus 4, if I'm correct. 2A plus 4 equals, and now I have to look, so that's on the top side, and it must be equal to 3A plus 2. Yeah, so I add up all those numbers and I added up those numbers, and they must be equal because it's a square. So that's very easy if you solve this. So that's a linear equation. A equals 2 is the solution. So now we have found that this length is 2. So that means if you add them all up, that the large square has length 8, has side length 8. So that we already know, side length 8. Now, finally, well, basically now let's first find the length of the areas on the top of the diagonal. So obviously the red area is 1. Yeah, that's easy. And this one is also easy because it's A is 2, so the blue area is 9. And well, if you use Pythagoras, you know that the green side is 1 plus 4 is 5. So you know that, well, the square of the green side, you know that the green area is 5. So we have already found 3 of the colored areas. What remains to be found is the yellow area. Well, therefore we can use this right triangle, that is a 2 by 3. Let's see if that's, well, okay, that's easy because here we have 3, here we have 2, so this easily is seen to be 3. So that means that the yellow side is squared, so the yellow side squared is 4 plus 9, which is 13. So the yellow area is 13. Yeah. And so if we add up, so we can find that the colored area is 1 plus 5 plus 9 plus 13. Well, let's see, that's 10, 15, that's 28. And we know that the total area is 8 squares, so it's 64. So the fraction equals, and you can divide by 4, so you get 7/16. So that's the answer to this puzzle. The colored fraction is 7/16.